Hello everyone. In this session, we are going to discuss about one of the important topics in fluid mechanics 2, belonging to the S4 syllabus in KTU. In module 6, we have a topic called model analysis and model testing. So we are going to discuss in detail about model analysis and model testing. So before going to the topic in detail, let us understand about what is a model. So what is a model? In hydraulic engineering, before construction of a hydraulic structure such as spillways, dams, cross regulators, or hydraulic machines such as turbines, pumps, etc. Before construction of the actual structure, we will be constructing a model of the actual structure, and various experiments are conducted on these models. What is the reason why we conduct experiments on models? The reason is that the experimental results are more validatable than theoretical values. So for example, if you are taking the construction of a dam, we know that a dam is a massive structure, a costly structure. So after construction of the dam, any changes to the structure is difficult. So before construction, we should make sure that our design is exact and maximum performance is obtained from the constructed hydraulic structure. So to make sure that our design is correct, we will be constructing a small model of the actual structure, and all the experiments will be conducted in this model. So the results from these models is evaluated, and we can predict the performance of the actual structure. And this process of making a small model of the actual structure and conducting experiments on these models is known as model analysis or model testing. So there are certain criteria that we should keep in mind while making a model of a particular structure. Structures can be of different types that I have already told. That is, we have discussed in the first module, second module, etc. about various hydraulic machines such as turbines, pumps, and various hydraulic structures such as dams, cross regulators, aqueducts, etc. So structures can be of different types. While we are creating a model of a particular structure, we should make sure that the model is similar to the structure that we are constructed. That is, the idea is that the model which we are constructing should be similar to the actual structure. What do you mean by similar? How can you make a model similar to the actual structure? So let us discuss about similarities, or how we can make a model or replica of the actual structure which is similar to that structure. So first of all, before going to model analysis or model testing, let us understand about similarities. Similarity between prototype and model. So let us discuss about types of similarities. It is otherwise known as similitude. So while making a model, I told you earlier that the model should be similar to the actual structure. So there are mainly three types of similarities. The first one is geometric similarity. Second one is kinematic similarity. And third one is dynamic similarity. Let us see one by one. What is the difference between geometric similarity, kinematic similarity, and dynamic similarity? So, in short, we can say that while making a model, A model should be geometrically similar to the actual structure, kinematically similar to the actual structure, and dynamically similar to the actual structure. And in model analysis and model testing, the actual structure is known as prototype. So from now onwards, instead of using the word actual structure, I will be using prototype. That is, for example, if you are designing a dam, that actual dam is called the prototype, and the model or the replica of the actual structure is known as the model. So here we are going to differentiate between prototype and model. So between prototype and model, these three similarities should exist. Only then we can compare the experimental results with the actual result. So first, let us discuss about geometric similarity. Geometric similarity. So from the name itself, we can understand what is geometric similarity. A model and prototype should be geometrically similar. Geometry, what do you mean by geometry? Suppose we are constructing a dam or a hydraulic turbine or a hydraulic pump and we are creating a model. The model should be geometrically similar. That means the size may be different, but the shape and form should be same, or the geometry should be same. I can explain this with an example. So consider an actual structure. This is just an example. Let this be a structure which you need to construct. Okay, that is prototype. The actual structure is called prototype. So this is the prototype. So a prototype will be having its dimensions. Let L be the length, H be the height, and B be the breadth. Since all these dimensions are belonging to the prototype, I am giving an additional notation, that is LP, length of the prototype. Let LP be the length of the prototype, HP be the height of the prototype, BP be the breadth of the prototype. And what our requirement is that we need to construct a model, geometrically similar model to this prototype. So a geometrically similar model may not be of the same size. Size may be different because we are constructing a dam and we are constructing a model of the dam. So model of the dam will be always smaller than the actual dam. So here if we are going to construct the model of this particular prototype, it may be smaller, but it should be geometrically similar. So let us consider the model of this prototype. So I am constructing a model of this prototype which is smaller than the actual structure. Since it is a model, I am dimensioning in this way. That is, let LM be the length of the model, HM be the height of the model, and BM be the breadth of the model. Okay, P stands for prototype and M stands for model. So this is our prototype and this is our model. And we can say that this model is similar to this prototype if their geometry is same. That means their linear dimensions possess same ratio. That is, in mathematically we can say that the ratio of lengths, the ratio of height, the ratio of breadth are same. That is, mathematically we can write, mathematically for a model to be geometrically similar to the prototype, the condition is that LP by LM, that is ratio of the length of the prototype and length of the model, should be equal to height of the prototype by height of the model, and that should be equal to breadth of the prototype by breadth of the model. Okay, so this is a condition for geometric similarity to exist between a model and a prototype. And this ratio can be represented as LR. And LR is known as linear scale ratio. LR is called linear scale ratio. So that is the explanation for geometric similarity. So a model and prototype are geometrically similar if their linear dimensions possess equal ratios. That is length by length of the prototype by length of the model, height of the prototype by height of the model, breadth of the prototype by breadth of the model. If it is equal to a single value equal to LR, we can say that model and prototype are geometrically similar.